I finally understand why refresh tokens are so important, and I want to share that in this video. So when you ask somebody what a refresh token is, or if you're somebody who have implemented one, the basic idea is that a refresh token exists to create new access tokens when the previous access tokens expire. So instead of having your user authenticate and create a new access token, and then after 5 or 10 minutes when that access token expires, they have to log in again and authenticate themselves for a new access token, you have your refresh tokens so that your access tokens can be regenerated. That makes sense on the surface. But then my question goes, why can't we just make an access token stay for a long time? Well, why you don't want to do that is because if that access token for that user gets into the wrong hands, that other person can impersonate that user and they can do things on the system for as long as that access token is valid. Okay, makes sense. But if you make your access token 5-10 minutes and it expires, but then you have your refresh tokens which last longer than access tokens by design, let's say the refresh token lasts for like a week or a month, it also means that if the refresh tokens gets into the wrong hands, that wrong person can generate new access tokens when they expire and still do bad things in person of the user who was actually authenticated. I don't know if you see where I'm heading to with this question, but it just never made sense to me why we needed to have 2 tokens for one user, but it does. So let's just get straight into it. Now, in a traditional setup, even before access tokens, JWT, before they became a thing, what we usually had was that when a client logins to a server, authenticates themselves, the server generates a session object. And this session object is saved in the DB. This session object will have its ID and it will also have information of the user that authenticated themselves. And then the session ID is sent from the server to the client. Now, whenever the client makes a request to the server, a user wants to access a protected page or they want to just perform an action that requires authentication, the client, in this case a browser, would send the session ID to the server along with their request of what the user is actually trying to do. And then the server would check the database for a session that has this ID, check the user attached to that attached to that session or assigned to that session, and if that is valid, the session has not expired, then the server can verify that this session ID is authenticated, it is the user, and then this user can do authenticated things. But one problem you see here is that you always have to go to the database to check. The client sends session ID, you check. Now imagine you have like 100,000 users. They are all clicking buttons, performing different actions that requires authentication. It means for every user and for every action they might be doing in whatever period of time, let's say in an hour or even in 1 minute, you are going to the DB to check, going to the DB to check, going to the DB to check. So from this, you see that we need a way where we can have the client have a particular information that is generated from the backend, but in that information, we can already see the information about the user without having to go check the DB to know the information about the user. And this is where the idea of tokens come in, like JWT, JSON Web Tokens. The idea of a token is that a user, let's keep this session ID and session here. A user logs in, authenticates themselves on the backend, and then the backend would generate a token. This access token will have a couple of information like the user information, when the token is going to expire, and any other thing that, based on what you're trying to implement, any other information you might need, you can store that in this token. This is generated on the backend using a secret string or bunch of characters that nobody should know. That's what makes this token unique to this server. By the way, if you don't know how JWTs even work in general or how to create tokens, I would share some resources in the video description for you to check out. In this video, we're talking about refresh tokens. So when this access token is generated on the server, it is now sent to the client. And now on every request, the user clicks a button, they try to perform this action, they try to filter this table, they try to call this API, they would send this access token along in their request to the backend. And then the backend can decode this token to see what information is stored, has this token expired, who is this particular user. They can do that, and they can also verify the token. By the way, if you already know JWT, you already know the difference between decode and verify. Decode just means breaking the token down into whatever information is stored in it, the user's name, when it will expire, all of that. Verify means that you're checking that this token is valid, and this is where the secret that you used in generating the token will be important. So for decode, a different system can decode this token and get the user information. So you also should not store important or sensitive data in the token. Anybody can decode this token, but only your system can verify the token, because your system has that secret information that is added when generating the token. So when it sends this request, the backend would verify that token, and then the user can do stuff. This is much more efficient than always having to go to the database, reading the database. No, you just generate or decode and verify the token as it is and let the user do what they need to do. The problem now is, if your access token would take, for example, a week to expire, what that means is if this user loses this access token for whatever reasons, maybe a hacker gets into their system or whatever, and then they have access to this access token, now the hacker can do things on the server in person of the user that logged in here, because all the server sees is that, is this access token valid? Okay, it's valid. That means the user is authenticated. And this is where it is recommended that instead of having long periods of time for your access tokens, you have very short time, like maybe 2 minutes, 5 minutes. So even if this access token gets in the wrong hands, they can only do bad things for like 5 minutes. But this brings a problem for the actual user. Now they have to log in every 5-10 minutes to get new access tokens, because the previous access tokens expired. Well, this is where refresh tokens come into play. The idea of refresh tokens is that you have your access token, which is, for example, 5 minutes expiry, and you have your refresh tokens, which is like, for example, a month before it expires. And what happens in this flow now is that the client keeps sending the access token, but then when it is expired, then the backend will be able to read this refresh token, which by the way is saved on the database. I forgot to mention, this refresh token is actually saved on the database, but the access token is not. The access token is just decoded and verified here, but this is saved on the database, and you'd see why this has to be saved on the database. So like I said, the access token keeps going until it is expired, but then instead of the user having to log in again, the refresh token will be sent to the server. The server would check if this refresh token exists in the database. That is the way the server knows that, okay, I can actually generate a new token for this user. Because if it doesn't exist in a way that the server can check, how does the server know? You're basically just telling the server, this is a refresh token, generate a new access token. But then the server can now check, this exists in the DB for this particular user. Okay, let's generate a new access token. And then a new access token is generated here and sent again to the client. Now this depends on how you implement yours. It's possible you send the access token, send, and when it is invalid, you now have a different endpoint like /refresh, and then you send the refresh token there. You can either do it like that, or you can send the access token and the refresh token at the same time, and then the backend can now decide when to generate a new token. That is when it sees that the access token is expired. Now, why can't you keep the access token for long? Well, that's clear. Somebody can impersonate the user. But if you keep the refresh token for long and it is also stolen, or somebody can also perform different actions. But here is where things get interesting. Let's say the backend notices that this particular user is calling the refresh an interesting number of times, or it just notices something wrong, or maybe the IP address changed from where this saver is coming from. That IP address could also be saved in the refresh token just as a way to verify. When the server notices something like that, the server can now choose to delete the refresh token from the DB. And what that means now is, even if this information is stolen, when the refresh token goes to the backend that, hey, give me a new access token, it checks, oh, this is not in the DB, well, it's not going to generate a new access token. The user will be forced to authenticate again, where they now have to provide their username and their password, or their email and their password. which hopefully the hacker does not know. So from all of this, why is a refresh token very important? Well, the first reason is you want to have a good user experience where user doesn't have to log in every 5 minutes because you are trying to keep your tokens to expire as quickly as possible. So by having a refresh token, it's a way for you to tell the backend that, hey, you can generate a new access token for this user. All is good. All is fine. Remember, again, the refresh token has to be in the DB for that to happen. But the second part, which I think is actually the most important part, is security. An access token by itself is stateless. It cannot be revoked. The only time it can be invalid is when it has expired or when it doesn't match the verification when you try to verify that token. For as long as an access token has not expired and the secret on the backend that was used to generate the token, as long as that has not changed, an access token is still valid. So even if a user logs out of their system and this access token is deleted from cookies, local storage, however it is stored, the access token is still valid. So even if this access token was deleted from the browser, but then a hacker still has access to it, the hacker can still access this system for as long as the access token has not expired. But then what you can also do when a user logs out is that as you delete this from the user storage on the front end side, you also delete this refresh token. So even if this access token gets exposed to a fraudulent person, yes, they will still have access to the server, but they only have it for a limited time. And when the access token is now expired, because there is no refresh token, you already deleted it when the user logs out, there is no refresh token to generate a new access token. Now the hacker or the fraudulent person cannot do anything. This is where that control and security comes to the backend. With just the access token, the backend cannot directly revoke it or say this is not valid, except it introduces other things. But by having this refresh token, you can ensure that when an access token expires, a refresh token is when an access token expires, a new access token is never created for that client.